Welcome IB Math SL students. We're taking a look at paper 2 from the May 2018 IB exam. We're going to go through the first 4 questions in this video. So let's go ahead and get started. Just a reminder that this is the calculator section. So here's problem number 1 worth 5 points. That tells us it shouldn't be too terribly difficult or take too terribly long. We have some function, f of x is equal to natural log of x minus 5x, and notice that it's for x greater than 0. So let's start off by finding the derivative. So f prime of x equals, well, the derivative of the natural log of x is 1 over x, and the derivative of minus 5x is simply minus 5. You can leave it like that. That would get you full points. But I notice that for part B, it's going to ask me for the second derivative, so I'm going to go ahead and rewrite it as x to the minus 1 minus 5. Either answer is perfectly fine. Let's move on to part B. Here we're asked to find f double prime of x. That's where I'll go ahead and use this second form of f prime of x. Remember, the minus 1 comes out in front, and we drop the exponent by 1. So I'm going to get minus x to the minus 2, and the derivative of negative 5 is 0. So I'm going to rewrite this negative x to the minus 2 as minus 1 over x squared. Finally, for part C, we're asked to set the derivative, this right here, equal to the second derivative. Well, I guess we'll just go ahead and do that here. I'll set 1 over x minus 5 equal to minus 1 over x squared. I'd like to get rid of my fractions, so I'm going to start by multiplying both sides by x squared. When I multiply by 1 over x, I just get x. Then I'm going to get a minus 5x squared, and finally equal to minus 1. I think I'll move everything to the right hand side, so I get 0 equals positive 5x squared minus x minus 1. Alright, so that's the quadratic that I need to solve. Remember, this is the calculator portion of the test. So I think I'll just go ahead and solve that here. I'll use apps, and I'm going to look at simultaneous equations 2, the polynomial root finder. Notice that the order is 2. Everything else looks fine. I'll hit next. And I need 5x squared minus 1 minus 1. And now I can go ahead and hit solve. I get 2 answers. I get x equals negative 0.358 and positive 0.558. Now, it's rather important that I go back and notice that in the original question it said for x greater than 0. So because of that, I need to eliminate the minus 0.53 or 358, and here's my final answer, x equals 0.558. Here we are with problem 2. Looks like we have an expectation value, and first it says that we need to find the value of k. So in order to do that, I need to remember that the sum of the probability is equal to 1. So I'll write 0.28 plus k plus 0.15 plus 0.3 equals 1. It's a simple matter from there to go ahead and find k is equal to 0.27 exactly. For B, we're asked to find the expected value of the score. So remember, that's going to be our x value times our p of x. So that's going to be 1 times 0.28 plus 2 times 0.27 plus 3 times 0.15 plus 4 times 0.3. And all of that added up equals 2.47 is what I get exactly. You can double check that on your own. Okay, for part C, the die is rolled 80 times. On how many rolls would you expect to obtain a 3? Well, if I look up here, the probability of rolling a 3 is 15%. So I need to find 80 times 0.15. And that looks like I would expect it to show up precisely 12 times. Here on problem 3, it looks like we have a bit of a trig or geometry problem. Not quite sure yet. We'll see what we get when we get into it. But here's our figure, and it says find the area of the shaded region in terms of theta. Well, in order to do that, I need to first find the area of the entire sector, so everything that's swept out by that angle, and then I need to subtract off the area of this isosceles triangle. Notice that it is isosceles because that side over there is 4 also. Okay, so first it tells me to do this in terms of theta, and it tells me, by the way, that theta is between 0 and pi, which that's what it looks like. Okay, so let's go ahead and do this. I'll find the area of the sector first. That's equal to 1/2 times theta times the radius squared. Remember, theta needs to be in radians. So that's 1/2 times theta times 4 squared. So that's going to be 16 divided by 2. So there is 8 theta. Okay. Now I need the area of that triangle. So I'll write area of triangle. Well, I notice that this is a side angle side triangle, so that means it's 1/2 times one side, which is 4, times the other side, which is 4, times the sine of the angle between them. So that looks like it's 8 sine theta. So the area of the shaded region, I'll just write shaded area, equals the sector minus the triangle. So there's 8 theta minus 8 sine theta. Now you could leave it like that, or if you want to factor out the 8, you could write 8 times theta minus sine theta. Doesn't really matter. Okay, now it says for part B, the area of the shaded region is equal to 12, and we have to find theta. So I'll simply set 12 equal to 8, then theta minus sine theta. Now it's really important that you remember that your calculator needs to be in radian mode, and I better get out of this. So notice that it tells me I'm in radian mode. I'm going to go right to my solver, so that's math, up arrow, enter. Clear this out. On one side I'll put 12. On the other side I'll have 8, and then in parentheses, x minus sine of x. And the first parenthesis closes the sine, and the second one closes the x minus sine x. I'll hit OK. The answer is between 0 and 0 and pi is about 3.14. So this is a good enough guess. This is not the answer. I need to hit the solve button right here to find the answer, and I get 2.27 to 3 significant figures. So I'll write theta equals 2.27, and I can just leave it like that. I'll go ahead and add radians. You don't have to. And that's all of problem number 3. On to problem 4. Here we have an equation for a parabola, g of x, and it says write down the coordinates of the vertex of the graph of g. Well, I can just look at it. It's x minus h, it's a times x minus h squared plus k, and so my vertex coordinates are simply positive 1, comma 5. Right? Then it says let f of x equal x squared, and there is the graph right here shown below. And it says the graph of g intersects the graph of f at x equals -1 and -2, and we're supposed to sketch the graph for g between -2 and 4. So first off, I'll go ahead and mark my vertex up here at the point 1, 5. It intersects right here at -1 and at positive 2. So I know it's going to intersect there. The line of symmetry will go down through here, so I know that I'll have a y-intercept of 0, 4. I also know that I need to be 2 units over here. So notice it goes 1, 1, 2, 4, and then it's going to go 3 and down 9. So that will put a point right here at -2, -4, as well as 4, -4. Okay, so I'm going to go ahead and sketch that. I apologize that I'm not a better artist, but here we go. There's the left-hand side. And now for the right-hand side. Notice as well that I'm stopping at -2 and positive 4. Okay. Lastly, it says find the area of the region enclosed by the graphs of f and g. So as I look at it, it's talking about this area right here. Now the area is just the integral of the upper function minus the lower function. And so I'll go ahead and write that down. That area equals the integral. And notice I'm going from -1 to positive 2. Those are my x limits. So I'll go from -1 to positive 2. And my upper function is minus x minus 1 squared plus 5. There's my upper function. Minus my lower function, which is just x squared dx. Now I suppose we could do this by hand. I don't think that I'm going to, though, because this is the calculator section of the test. I've already written down my work for it. So let's go ahead, alpha window number 4. We're going from -1 to positive 2. And here I'll go minus parentheses x minus 1 squared minus 5. That looks like everything I need there, dx. And it looks like I'm getting an answer. Oh, wait. Huh. I'm glad I caught that. That's a bit of a problem. I forgot to insert minus x squared. Let me make sure that I got everything in there correctly. I did not. I messed up something again. Ugh. This is plus 5. Now let's try it. There we go. Third time is the charm, and I finally get the correct answer of 9. And there all is everything that we need to do through problem 4.